So here we go with example number 29. Our charge is to find the slope of the circle x squared plus y squared equals 25 at the point where x is equal to 3 and y is equal to -4. And we're really having no idea of where to start with all this. But if you had to start, and again, our goal is to get the derivative, how do you think you would personally start by deriving x squared plus y squared equals 25? What would you do first, especially seeing that the first term is x squared? Yeah, you're probably thinking to yourself, well, x squared derives to 2x. And that's exactly what we want to do for our starters here as well. We're going to derive both sides of the equation. We're going to derive every single term. Well, the first term that we see is x squared. We know how to derive x squared. It derives to 2x. All right, so that's our first key for implicit differentiation. Derive all of your x terms as you would normally. Now, we have our plus sign. So we know that when we add or subtract, our sum difference rule says just keep deriving term by term. The next term is y squared. What do you think about that? What's the derivative of y squared? Well, if the derivative of x squared is 2x, it seems reasonable that the derivative of y squared would be 2y. And that's correct. All right, y squared will derive to 2y, but there's a little bit more. Okay. Ultimately, what we're doing here is we're deriving each term. Let me continue that phrase. We're actually deriving each term with respect to x. Okay, that's why x squared derives to 2x, because we're deriving with respect to x. This is not an x term. It's a y term. We're taking the derivative of y squared with respect to x. So what does that mean? Well, we derive y squared using our same derivative rules. Okay, but we have to take into account that we're deriving with respect to x. In essence, we're doing a chain rule here, which is why we introduced this topic after we introduced a chain rule. Okay, we don't have x squared. We have an inner function squared. That inner function is y. All right, so what do? Chain rule says derive the outer function. Well, something squared goes to 2 times something. Keep the inner function, so we're keeping the y, and then multiply by the derivative of the inner function. Okay, now what's that going to be like? Well, the inner function is y. We're taking the derivative of y with respect to x. We have a term for that already. The derivative of y with respect to x is dy dx. Okay, so the derivative of y squared will be 2y times dy dx. Every time you derive a y term when you're using implicit differentiation, you must include a times dy dx at the end of that derivative. Okay, so as you'll see with future examples, but every time you derive a y term, it needs to have a dy dx. Otherwise, you are not deriving correctly. Okay. We're not done yet with our derivative. We have to derive both sides. So we have our equal sign, and then we have 25. What's the derivative of 25? Exactly, it's 0. Okay, so our key steps so far: derive both sides of the equation. Derive x terms like we would as usual. Derive y terms like x terms, but there should be a dy dx multiplied on the end. Now that we've done that, we want to get all the dy dx terms all by themselves. This is a good thing for us to have a dy dx right here. That means that we have something to solve for. Remember our goal: get the slope of the circle. Well, what's the slope? The derivative. And this term represents the derivative. So we got to solve for it. How do we solve for it? We got to get it all by itself. How do we get rid of the 2x? Exactly, we're going to subtract it. So we're going to get the non-dy dx terms over to the other side. That means that we have 2y dy dx is equal to negative 2x. And now that all the dy dx terms are over the side, if we have multiple, as you'll see in some future examples, you can have more, 2 or 3, 4 dy dx's in one equation. Got to get them all on the same side. We'd factor them out so that there's only one. That's not the case here. We only have one dy dx. We can solve for it. We just need to divide. So we're going to divide both sides by 2y. And in doing so, we get dy dx is equal to, we can cancel out the 2's. Is that okay? All right, so the 2's are gone. The opposite of x divided by y. That's our derivative in general. It's got x's and y's. That's fine. Our original equation had x's and y's. No big deal. Okay, so there's our derivative. Remember, we're charged with finding the slope at this point. So we now have to plug those two values in. We replace all of our x values with 3. We replace all of our y values with -4. So we end up having -3, because again, x is replaced by 3, divided by -4, which obviously we don't need those negative signs. So we have a slope of 3/4. That's our answer. The slope of the circle at this point is 3/4. Let's do a quick visual and see if that makes sense. Excuse me. Here's our circle. Here's the point on the circle where x is 3 and y is -4. Let's draw a tangent line there again, just like we did in the last video. There's my tangent line. Remember, the derivative is the slope of the tangent to the curve at a point. Does it seem like that slope right there goes up 3 and over 4? Up 3 units for every 4 units that it goes over. It does. It's definitely not a negative slope. We shouldn't have a negative slope. We should have a slope of 3/4. And the picture, and I don't have the grids on there, the picture matches the calculus that we did. So this works out. This is implicit differentiation.